Hello everyone, this is Samirian, and today's tutorial is going to be on making our own currency system. And yes, of course, the first question you're probably asking yourself is why would you ever want to do that when we have some currency systems in the game already? We have the money manager, loot manager, inventory manager, the storefront, we have all these things already. Well, what I've found so far is for every single thing I've wanted to use money for in this game, it doesn't work properly. The money system really feels like they put it in to work with the Toy Box game discs for the tower defense systems, but other than that, there's really not a lot of usefulness to them. You can't go in and utilize the money as the Toy Box creator at all. I can't give you extra money if I feel like it. I can't take away money to perform other actions. I really just I can't do anything. I even once tried to make a toy box where I simply was trying to make the player buy uh, pack and tools type items. For example, maybe the jet board or something like that, just to get by to the next level. But you can't even do that with the money system. So what I've done is I've come up with my own way of doing a money system. And with this system, you have absolute control of it. You could have it cost 10, well, points, or you'll see what I mean. But I'm going to call it coins from now on, just because we're dealing with it as a money system. But you could set it up so you need 10 coins to open a door. You need 10 coins to buy a certain pack and tool. You could have enemies spawn on your side by the coins. You can do anything with this currency system that I've developed. So what we're going to do first is we're going to start with the basics of how it works, and we're going to build on from it from there. This will probably take more than one tutorial to go through the whole thing, but we can get the system created and show you how it's working in this first one. And what we're going to need is we need counters. And for every value of item you need purchased, you're going to need a different counter system. And for each value, let's say in this tutorial, I'm going to say it's going to cost you 5 coins. And then if you push a button and you have at least 5 coins, we're going to drop like a health capsule on you. And if you push another button, it'll also cost you 5 coins, and it will drop a power-up capsule on you. And so to do this, we're going to do the first system based on the value of 5. If you have 5, you can purchase it and we'll subtract 5 from your overall score. And if you don't have 5, it just won't work. So what we have to do, and I've tried many ways to do this, the last try was close, but it didn't work. But it led me to this method, which actually works really good. So that first counter, I set it to a count of 5, which is the value we're looking for. The second counter, I want to set it 1 below 5. So I'm going to set it to 4. And the reason we're doing this is because we're going to track everything by the target reach message of these counters. So once you've reached 5 and you go over it, then the system says, okay, you would be allowed to purchase this item. But the problem with doing it that way is if you're at, let's say you have 10 coins and I take 5 away, you hit this target reached, which switches you back in your system to say, okay, he doesn't have enough now, is the problem I was running into. And so even though you still had 5, you couldn't purchase the item again. It was even worse than that, but perhaps I can explain better as we go along. So how the system works is it's going to work on a flip-flop type system. We're going to go on the basic knowledge that logic gates are by default open when you start a toy box, and counters are set to 0. So when this game starts fresh, these counters are 0 and these logic gates are all open. So the first message I'm looking for is once you've hit the count of 5, I can say you will now be allowed to purchase the item. So what I'm doing is the counter target reach of 5 inputs to this first logic gate. And what it is going to do is it is sending its output, since it's open, to this final logic gate and telling it to close. And when this logic gate closes, I want to close this one as well. So now if I hit the number 5 again on the way down, the message will come in, but this gate is now closed, so it will go out input blocked, which is attached to nothing. So what we're basically saying is, if you've passed 5 on the way up, and if you've landed on 5 on the way down, we don't care. It's not a big deal. You're still 5 or over. On the way down, what I care about is I care about hitting the number 4. Once I hit 4, then I'm going to say, okay, you no longer have enough coins to purchase this item. So that's when this counter, which is set to 4, will fire off an input. Now, it's on the way up, it's going to fire off an input anyway, because you're passing 4 on the way to 5. So I don't want anything coming out of the output of this logic gate. I want it coming out of the input block, because if it comes out of the output, it's going to fire off a message before we hit 5. So I want to set input blocked, and I want to reopen this gate here. So you've gone over 5, this gate closes, you've hit 4 on the way back down, and this gate will open saying you can't purchase this item anymore. So how is it going to know whether we're going up or down? Well, what we're going to say is we've already attached the close to this logic gate. We're also going to attach the open to that logic gate. And we're going to tell this logic gate, if you open that one. And if you close that one. So what we've just done is you've started a count of 0. You start counting up. You reach 4. Sends an input to this logic gate, but they're all open, so the input goes nowhere. Then you hit 5, and the input hits this logic gate, which is also open. And this output tells this logic gate to close, which closes both of them. So now, you say you get up to 6, 7, 8, 9, 10, and then you subtract 5, so your count comes back to 5, and you hit the target reach of 5. Well, it will send an input again, but now these logic gates are all closed, and there is nothing attached to the input block of this logic gate, so nothing will happen. So this system will remain active until you hit 4, which will come into this logic gate, and its input block goes to open this, which opens all these gates. So you're now ready to hit the number 5 again. And once you've hit 5 again, it closes. You hit 4 again, it opens, and it just keeps going. And this is the best way I've found to track some sort of currency. Alright, so we've done that simple part. Now we're going to make 2 more logic gates here. I'll put one there, and I'll put one there. Now this logic gate is going to be the logic gate we use to increase our score. And it has to increase the score everywhere. So I'm going to increase by 1, that's the scoreboard, which is what is displaying our currency to the player. And I also have to increment by 1 both of these counters. And this logic gate will be when we're going down. So it is going to be attached to the scoreboard again to decrease by 1. And I'll do the same thing to both these counters. Now the important thing here is that we have to always go 1 score at a time. I'll show you a way to do it quickly, but the way this system works, you can't just increment by 5 all of a sudden. you have to do it one score at a time so that these counters will fire off in the right pattern to keep this logic circle working. And the way we're going to do that, because we're saying purchasing anything through this currency or this counter system here is going to cost 5. And we want to be able to remove those 5 really quickly. We have to do it one at a time to make it work, but we want to do it quickly. So we're going to build one of my little time delay systems. And we're going to put a counter on it so it tracks. And I'll show you what that means. So when someone purchases something, it'll send an input through this logic gate. And only if it's closed can you purchase. So the input block of this logic gate will start this system. So we're going to say, when this gate is opened, increment the counter by 1, and with an output, increment the counter by 1. And the reason I'm doing both is because the way this system works is once I'm done with it, the only way to stop it is to close this logic gate. So this logic gate, after the first time we do anything, will always be closed. So I always send input block from him, opens to him to start the count going. When I force him open, he'll send the count, and then this counter will say whenever the count changes, it inputs. So it also needs the output hooked up here over to increment this counter, because the counter is sending an input to it. Now, with these counters, it's very important. I'm going to set it to a target count of 5 to give us a decent speed, but also time for the rest of the system. Now, I'll go to 4. Why not? You always want to set reset on target reached to on, because you want the system to reset itself automatically. So what we're going to say here is when the target is reached, we want to decrease the score by 1, and we also want to increase this second counter by 1. And what this second counter is doing is it's going to count to 5 for us. So when we subtract 5, it's going to count that we do it 5 times, and then it's going to stop the system. We also want to make sure this one is reset on target reached, so the system is always ready to work. And the only logic we attach out of this counter is when you've reached the count of 5, close that logic gate just to stop the circuit from happening. And what this can do is it's going to subtract 5 from our count every time you open this logic gate. Now, I also want to show you a quick system on how we're going to quickly increase our score by whatever we want. And we're basically going to do the exact same thing, and the only difference is I'm going to hook it up to the increment +1 logic gate here. Now this counter, I'm going to give it a count of 3. So every time this circuit runs, my score will increase by 3. And to do that, all I'll do is I'll hook up just a little button to it. So there's our button right there, and when I push it, we'll open that logic gate. Because remember, it's going to close after the first time I run it, so it's easier to send an open to it than an input. And I'm also going to put in 2 trigger areas here. As I was saying, I'm going to design it so that one of them is going to give us a health boost, and the other one will give us a power-up boost. Alright, so I'm putting the locators right on those pads so that when we step on it, if we have enough, the items is going to appear right underneath us, and hopefully they'll just scatter right away. So, input blocked of him will give us a health capsule. And we'll just try that first before we make the second one work. Alright, so stepped on player any input. Okay, so if I step on this trigger, nothing should really happen, because we have not reached the count of 5 yet. Push that button, we've reached 3. Well, 3 is not high enough. I still won't get anything out of that trigger area. Okay, so I've adjusted this scoreboard here higher so that it won't do the reset on me, where it'll scroll through the number 3 and then start all over again. So I'm going to push this button, take us to the count of 3. This gate still won't do anything because we haven't reached the minimum of 5. Now I've hit 6. So if I stand here, there's my health capsule. If I stand on it again, I'm now under 5, or I've hit 4 on my way down, so the system won't work again until I've at least passed 5 again. Because see, I'm sitting on 4 here, but the system knows that because we're below 5, the 4 does nothing. So now we're going to go to 10 here, and I will stand on this board, and it will give me a health capsule. Now we're at 5, so we still have enough points to purchase this item again, and our system does know that because we hadn't hit 4 yet. And now that we have passed 4, our system knows, yeah, you don't have enough coins to do this. So that is part 1 of the tutorial. Part 2, I will go into connecting the power-up over there and also into adding more denominations into here and show you what kind of changes we have to make in the system to do that.